Hello everyone. So in this class we will learn about motion in one dimension, and it is also called as a rectilinear motion, and again this is one of the demo class for our upcoming coaching, which is starting on 23rd of November 2024, and we will have class on every Saturday Sunday from 5 p.m. to 8 p.m. till 31st March and 31st March 2025, and I will try to cover entire syllabus by then. Along with that, I will also conduct test series and doubt solving class. So let's start with the rectilinear motion. So in this chapter, you will learn about the concepts like distance, distance, then displacement, then speed, velocity, acceleration, and jerk. So I will just give an introduction to these concepts. Here I have separated these concepts like on the left and right, like distance and speed on left, and displacement, velocity, acceleration, and jerk on the right, because these are basically scalar quantities. And on the right hand side, we have vector quantities. Okay, so let's start with the distance. Just a second. Okay, so if we have point A here and point B here, and if we go by path like this to reach from point A to point B, then the distance is basically defined as the length of path traveled for reaching from point A to point B. So this is how we define the distance between A and B, or if you have to define distance between any two points. So you can simply write it as the length of path traveled from initial point to final point. So if we go by, let's say this is path one, so the length of path one will be different. So distance of A to B from path one, and let's say we have a different path two. So the distance traveled from A to B by path 1, like let's say distance 1, distance 1, it is distance traveled by path 1 is, like as you can see here, it is lesser than distance 2. So, so since we are the length of path 2 is more, so it is basically the distance between A and B by part 2 is more than distance by part 1. And this first of all, as I told, distance is a scalar quantity. Okay, and the definition is the length of path travel from reaching from one point to another point is a distance. However, like if we want to define the uh, what we what I told is uh, displacement. Okay, so let's draw this arrow from A to B. So displacement is, shortest distance between A and B, or for this case we have defined A and B, or you can simply write shortest distance shortest distance between or from, it is the shortest distance from initial position to final position. So here in this case, as you can say, A is the initial position, B is the final position, and we have drawn arrow from A to B, which is pointing towards B, and it is basically showing that we are moving from A to B. So displacement is a vector quantity, because as you can see we have an arrow from which is pointing from A to B, because we are going from initial position A to final position B. So the direction is from A towards B, and therefore this arrow is pointing towards B, and of course it has the magnitude, which is the shortest distance from point A to point B. Okay, so let's say, mm, if you get like if we have to define, so- okay, so as we have defined, the displacement is the shortest distance between initial position and final position. So if we have to write a relationship between distance, or we have to write some mathematical identity between distance and displacement. So in this case, if instead of taking this path 1 and path 2, we simply, let's say, traveled by this arrow only, then the distance and displacement in that case will become equal. So the distance is always greater than or equal to displacement. So it, if we travel like from A to B, a shortest path, then displacement and distance will be equal. However, if we take other paths, then of course the distance by other path will be more than the displacement. Therefore, this is really important thing, like this distance is always greater than or equal to displacement. Okay, so okay, we'll take one example to find out like the magnitude of distance and displacement. Okay, so here we have a man which is standing at initial position A, and his final position is B. Okay, so let's say there is it he is traveling from A to point C first, and then from C to point B. Let's say the distance between A and point C is 3. The distance between C and point B is 4. So he has traveled from A to C and then C to B. So the total distance covered is basically total distance covered will be equal to 3 plus 4, that is 7. However, if we have to find the displacement, so as we know that it is the shortest path traveled. So here you can see we have this as the shortest path traveled by reaching from initial position A to final position B. and therefore the displacement will be, as you know, as we know, this is a right angle triangle. So from Pythagoras theorem, we can say the displacement is equal to of 3 square plus 4 square, which is equal to 9 plus 16, which is equal to root 25, which is equal to 5. So here we have found that the distance covered for reaching from A to B was 7, as he has traveled from A to C, then C to B. However, the displacement was only 5 from Pythagoras theorem. Okay. So similarly, we will take example of a speed and velocity. Okay. So speed is basically defined as distance upon time. So if we like, if let's consider, mm, okay, again consider initial point A, final point B, and the distance between A and B is 10 meter. And man started walking from A to B, and he has covered this distance within 5 seconds. So in this case, the speed will be equal to, distance is basically 10 meter, time taken was 5 meter, 5 seconds, and therefore the speed was 2 meter per second. Okay. Similarly, we defined velocity as displacement upon time. Actually, we will stop here, and because this was just a demo class, and we'll continue, or we'll learn everything with details in uh, actual classes. So I expect all of you to join this coaching for physics, because I am planning to teach every concept in very detail, and I will also conduct demo classes, so that if you have any doubt, I will clear those doubts in demo classes, and I will try to provide the personalized attention to everyone. Thank you.